couldn't attend the classes because of work, and he's been watching the videos, and he says they really help. So we'll keep going.
Lucas is a liar.
Who is a liar?
I don't know. I spit out a name.
I don't think it was Lucas. Uh, but anyway, maybe he said that to make me feel better, which if he it made me feel better. Nothing wrong with that, right? Okay, so today take up our last topic in this chapter, and we'll deal with what happens at the end of the chapter when we get there. I have some ideas, but we'll talk some more later this week about that. But the last topic is what happens when we sample from a population, and the sample we're taking is a bunch of data that we can calculate the mean, data for which we can calculate a mean. In other words, it's something we measure, like student heights or GPA or distance to school or whatever. It's something we can measure. Last week when we were talking about sample proportions, those are things that we can count. People in favor of the governor's strategy, number of red poker chips in a bucket, number of assignments you've completed on time during this outage, whatever. It's something we count. When we're talking about sample means, those are things that we can measure. And so today I'll introduce the formulas to you, and they're really simple. And I'll walk you through an activity to try to introduce to you the process. And so our assignment at the end of the day will be to complete some data on a Google spreadsheet that I'll share with you. And we need several samples in order to be able to create a graph. If we were doing this in class, we would take our samples and we would create a dot plot right here, right in the classroom. Well, we can't do that. So I'm going to ask you to add your data to a spreadsheet that is shared with all of you. And so, and after we get several samples, then we'll take the next step and we'll make some graphs and see what we come up with. Okay. All right. So just to refresh, if we have a sample proportion, the mean of p hat is just equal to the sample proportion p. The standard deviation of p hat is the square root of p times 1 minus p over n, as long as the 10% condition is met. Okay, always check that 10% condition and make sure it's met. If it's not met, then we're done. We have to figure out some way to gather the data that we need or analyze the data that we need. So today we're going to talk about sample means, and I'll just jump straight to the gist of the chapter. And if you've got your book in front of you, you want to turn to page 444. And at the top there, it tells you the mean of the distribution. So this one will be the mean of X bar is simply equal to X bar, the mean of the population. Or in this case, since it's a population, we want to use the population terminology, mu there. So the mean of X bar for all the samples that we take, when we add up those samples and we calculate the sample mean X bar, the mean of all those will just turn out to be equal to the mean of the population. And the one we have to pay attention to is the standard deviation of X bar. It's equal to the population standard deviation divided by the square root of n. Okay, so that's different than with the sample proportion. and it's really, really, really easy to get that mixed up. But just let me share the screen here for just a second. And kind of refer you back to your formula sheet. Hopefully you can see the formula sheet here. It's on the right-hand side of the formula sheet. Here we have for a single sample, the statistic is the sample mean. The standard deviation is the population standard deviation divided by the square root of n. For a sample proportion, it's right here. So these two standard deviation formulas are right there for you in case you get stuck on the exam or on a quiz or anything that you might need those formulas. Let's see. So yeah, I'll just leave it right there for now. But those formulas are there. They're available for you. Just don't forget what they mean. Okay. And oh, by the way, let me turn this off. We'll come back. By the way, I do have some information about the AP exam, and remind me at the end to share with you what I've learned today.
Share it now, because now I'm curious.
You're curious now? Okay. Well, there are one of two options. Every student can request a 5 on the exam, or you can take it and see what you get. Just kidding. That's not it.
How dare you?
That would have been good.
You got me. You got me.
I got you. Now that you're listening, anyway. The AP exam will be available in a test from home option. And right now, it appears that that test from home option is a multiple choice only test.
Ooh.
And the College Board says that they've contacted universities and they've surveyed literally thousands of AP students. I don't know, maybe y'all have gotten a survey. I don't know. But
No.
all the colleges and universities have committed to giving you credit where credit is due. So if you earn a 3 or a 4 or 5 on the test, then even though the test is different, will be different than previous tests, they're still going to honor that. So I feel like that's really good news. That was kind of a relief from me, or for me, because I really didn't have any idea what's going forward. Now, there still are some uncertainties when the test will be administered and exactly how. And as I get updates from them, I'll pass those along to you. The other thing is they have trimmed the amount of data, the amount of chapters in the book that we need to cover in order to get ready for the test. So that's good news. So I really think the College Board is doing a great job of being mindful of what's going on and give you guys an opportunity to still go ahead and get it. Now, assuming we come back to school before test day, we may take the regular test. I don't know. But assuming we're out through the test period, the testing window, then
when is our test supposed to be?
it's the very last Friday of the test window. I think it's May 15th. I think it's May 15th. I'll look at that between now and tomorrow, but I'm pretty sure it's May 15th, or would ordinarily be May 15th. Now, things are changing. I don't know when it's going to be. What I do know is that, and what we will probably do for this chapter is I can create a test on AP Classroom. Like I've been sending these little sample, I don't really call them quizzes, but they call them quizzes. And I can send it to you, and I can establish a time limit. I can say you have 60 minutes from start to finish. There is software to lock your browser where the only way you can take the test is to lock your browser first. Now, obviously, there are ways around that, but the idea is for you to test in as normal as you can. But quite honestly, if I'm going to give you a test that I expect you to take at home, I'm going to consider that you're going to have your notes in front of you and your textbook in front of you. And quite honestly, that'll be fine with me. So when we get to it in this chapter, and it's time to test over this particular unit, that's what we'll do. I will send you a test, the open book-ish. And to be honest and not get your buddies on Snapchat and share your answers back and forth. But if you want to use your notes in your textbook, that's fine with me. This stuff is hard enough as it is, especially where we are right now. I have given this test in Chapter 7 as an open book test before anyway. So that's not unusual for me to do that, or at least open notes. Probably not because we don't use the book that much in class, but I have allowed students in the past to have their notes out. So just to give you a little bit of a comfortable feeling, help you out as much as I can as we go. To make this real, we have to, and that's what we'll do. Okay, so as I find more info about the AP exam, I'll let you know. But today they did post a message for us to look at, and I'm hopeful that they would do something like this. And looks like they're working with us as well. So that's good news. Okay, let's get back to what we were talking about. So if we're looking at a sample population or sampling from a population where we calculate the mean of a set of data, the mean of X bar is equal to the mean of the population. And the standard deviation of X bar is equal to. Now, you might ask the question, and it's a really, really good question to ask. How do I get this number? If it's a population, generally you don't have them. In the real world, you don't have them. And so that's why we do sampling. We take lots and lots of samples and we put them together, and we take that data and we begin to use it over and over. The values in the real world are hard to come by. In the academic world, usually they'll be given to you with a sentence that begins with something like, suppose the mean height of adult males in the U.S. is 72.4 inches, or whatever. It'll be given to you some way in an academic setting. But in the real world, these two things are hard to get. So that's why we do so much sampling. That's the purpose of sampling, is to try to figure these values. Okay, so, the other thing is, and this is if the 10% condition is met, N is less than 1/10 the size of the population. Okay, so N has to be small compared to the population size, just like we had over there for proportions. Now, the cool thing is when we talked about a sampling distribution of sample proportions, we talked about the center, we talked about the spread, and we also talked about the shape. And tomorrow, we'll talk more about the shape. And ultimately, it takes us to one of the fundamental aspects of statistics. And if you want, you can flip over a couple of pages. And it's this thing called the central limit theorem, And you might, when you read it and when we talk about it, it might sound like a get out of jail free card. And in a lot of ways, it kind of is. But the cool thing is, it tells us something really fundamental about this science of statistics. When we do sampling and when our samples are large enough, the data tends to behave in a really well-behaved way. And that's all I'm going to say for today. If you want to flip ahead and read about it between today and tomorrow, that's fine. But it's really, really, I think it's kind of cool. It's one of the reasons I like statistics, I think, because you can learn about populations even if the data in the population isn't well behaved to start with. So what I want us to do is I want us to look at the example that I posted. I posted on Classroom a little bit earlier. And it is, let's see. Can y'all see this? It says, in this activity, we'll be taking simple random samples. Can y'all see that now?
No, not right now.
No.
No, you can't see it. Okay. Okay, let me present in a different way then. I'll present my entire screen. Now can you see it?
Yep.
In this activity?
Yes.
In this activity, we'll be taking simple random samples. Okay. I posted this on Classroom, so you'll have this to go back and look at when we're done. But basically, what we're going to do is we're going to be taking a lot of samples from the distribution you see at the top of the page there. And that's just that's a really weird distribution. It has a special name, and we may get to it at the end. We may not. We'll talk about it before the end of the class. But anyway, all we really need to know right now is that it's clearly not a normal distribution, right? This is not single peaked. It is not bell shaped. It is not symmetric. Well, maybe it's symmetric about a line like y equals x, but it's not symmetric in the way we're used to seeing symmetric. So that we would say this is not a well-behaved population at all. And so what we're going to do, we're going to take some samples using your calculator and the instructions below, and we're going to record that data on the Google Sheet that I will share with you when we're all done here. So how does this work? So let me pull up the calculator. Can you see the calculator now? Please say yes.
Yep.
Yes.
All right, good. Okay. So we're going to go back to this random normal function. It's very similar to the random binomial function that we were talking about last week. But because I'm collecting data from you guys and we're going to be using it, I want to make sure that we're truly generating random data. In other words, the data that Briley gets is independent from the data that Gracie gets, and from Riley is independent from Addie, and all of you, it's independent. And in order to do that, we have to seed this random number generator. We talked about this way back in the first semester. The calculators don't really generate random numbers. They use an algorithm to calculate a random number. And that they can fall into a pattern where we can force the calculators to give us all exactly the same number. So I want to make sure we force it to give us different numbers. And so what you do is you're going to enter a unique number that you think of. And it can be, I mean, you can just type in a bunch of gibberish numbers, which is fine as long as you put in 4 or 5 or 6 digits. But what I'm going to do, I'm just going to put in my birthday, 5/31/1966. I don't think any of you were born on the same day. And as long as you weren't, that's fine. You can put in your social security number. That's truly unique. You can put in your student ID number, put in your telephone number. That's a truly unique number. Any truly unique number is fine. And then what we're going to do is we're going to store that by pushing the store button here. When you see the little right arrow, that means we're going to store it in a certain location. And that location is, to get to it, we're going to click the math button. And then we're going to cursor over to the probability menu and choice 1, rand. So we're just going to hit that. So on your screen, you're going to put in some multi-digit number. If it's random, then make it at least 5 or 6 digits. If it's not random, it's your cell phone number. That's truly unique. Your student ID, social security number, anything that's truly unique. I'm certain none of you have my birthday. So, and yes, Gracie is rapidly trying to calculate how old I am, I'm sure. But I put this up so that you'll remember when to send me a birthday card.
Right.
Hint, hint. Okay. Anyway, once you hit enter, now the random number generator is going to take that unusual number and begin to generate random numbers. And if we all use a different seed, we all get different results. Okay. So if you're following along, when we go through this, you should see different numbers than I do. Okay, so now we're going to be down here at step 2. We're going to use the random norm function. And again, to do that, we're going to click on math and then cursor to probability. And random norm is choice 6. And so we're going to enter some values. The first 2 values are the mean and the standard deviation of our population. And so in this case, the mean is going to be 0, comma, and that's the key above 7, comma, the standard deviation is going to be 1. And we want to generate 5 random numbers from that population. And you can close the parentheses or not, it doesn't really matter. But once you get that function populated this way, hit enter. And again, you'll see some random numbers. Now remember, these random numbers will be centered around 0 with a standard deviation of 1. So you'll get some positive and some negative numbers. And it's hard to see them on your screen. So what we're going to do is we're going to store them to a list. Okay, so we'll click the store button, and it's what you see on your screen is we're going to take the answer we just got and we're going to save it to a list, and we'll put it in list 1. Okay, if you want to keep your list 1 from last week, pick one of the other ones. It doesn't matter. When you do this, it will overwrite what you were using last week. So if you need it, pick another list. So I'm going to store it in list 1. Now I'm going to go back to the stat editor by clicking the stat button and edit. And now in list 1, I see the random numbers that were generated. Again, I get some positive numbers, I get some negative numbers, but they're all clustered around 0. And I would really be surprised to see a number as big as 2.5 or -2.5. Certainly, it'd be very surprising to see a number like -3 or +3. But 1.5, anything less than 2 is not surprising. Remember, that's only 2 standard deviations away. So now I've got my 5 samples. So what this is, what list 1 represents is I randomly picked values from this distribution over here, and I picked 5 of them. So my sample size is 5. Little n is equal to 5. And this is the values I got. Hopefully you'll see different values on your screen. And so what we want to do is we want to calculate the mean and standard deviation of these 5 values, okay? So to do that, we go to the stat editor and then calculate. We want to do one variable stats for now. I want to use list 1. You can use whatever list you picked. But once we pick list 1, we'll cursor down, we'll hit calculate. And so now the mean of that distribution, the mean of that sample is a negative number, negative 1.614, and you can see the numbers, and you can see the standard deviation of that sample. And here we see a little bit of variation just because sample size is really, really small compared to the population standard deviation. But again, we're not going to be recording for this exercise. We're not really worried about the standard deviation of the data. We're just going to record the mean. And so how are we going to record the mean? We're going to put it in a spreadsheet. Now, do you see a spreadsheet on your screen right now? It should say sampling from a skewed population.
Yes.
You see that? Okay. So after you do your samples, I'll share this link with you, and so everybody will be. So you'll put your name in. This is how I'll know that you did it. And so I'm gonna put my name in here, and my first X bar was negative 0.1614, I think. Negative 0.1615. Let's make it accurate. Okay. And so there's my value. Just for grins, let's go back and do this again just so that we can walk through it. So to do this again, we can cursor back up and kind of copy that back into the editor again. And remember, the first value is the mean, the second value is the standard deviation, the third value is how many samples we want. So now I'm going to take another sample. I'm going to store that. This time I'm storing in list 2 so we can compare the two. Just look at them. Now I'll go back to stat and edit. And you can see I've got a different set of numbers, different set of values, and down here I've got a really, really weird one. Remember, anytime you see a value with an E, that means it's in exponential notation. What I have here is negative 8 times 10 to the negative 4th. So that is a 0.0008 is how that value would look in just the decimal format. Now I'm going to go ahead, I'm going to go back, I'm going to calculate them. Of course, the good news is I really don't need to know what that funky number is. I'm just going to calculate the mean. But it's a small number close to 0. So it's really, that's how we would interpret it. Now I want list 2, calculate, and now my mean this time is negative 0.02877. So now I'm going to go over here, Barry, negative 0.0287. We'll leave it like that. Okay. So now on the spreadsheet, you can see that we're going to do samples of size n equals 10 and size n equals 25. And all we'll do when we do that is you'll just change this value here from a 5 to a 10 or a 25. When you store them in a list, you'll have a list of 10 numbers or 25 numbers, same thing. Okay. So the cool thing is when we get several of these values, we'll create a dot plot. I will, I'm not sure. We'll probably do that in one of our video sessions. I'll use Fathom and input the data, and you'll see what the dot plots look like. And we'll see as n increases, n gets bigger and bigger, the shape of this distribution will look substantially different than the shape of that distribution. And neither one of them will look like the original shape. Neither one of them will look like this. Okay. And so it's really kind of a good exercise on what the sampling distribution of sample means looks like. Okay, so now as you go through here, store these values, find the mean, mark the value on the class dot plot. So for right now, we're not creating a class dot plot. We're creating a class Google Sheets, and we'll create the dot plot in another session. I don't know if it'll be tomorrow or Wednesday, but anyway, we'll come at this kind of slowly as we go. Okay, any questions?
Why does that say to square it?
Why does what say square?
Like it says rand normal 0, 1, 5 square.
This right here?
Yeah.
That's not a square. That is well, that's to generate, that would generate simply positive values. Okay.
Uh-huh.
Here I'm not so worried about generating positive values. We're gonna deal with the negatives and the positives as well. It just means the dot plot's gonna look a little differently than what you get here. So anytime you square a number, you make sure you get a positive value. And so what I should have taken that off there. I forgot to. I copied this from something from our textbook, and I forgot to take that off. Just ignore that square.
Okay.
And we'll go from there.
And are we supposed to answer the number 4 or no?
No, you can't do that yet. We're gonna have to look at our data first. Okay. So we will. All I want you to do between now and the next class is to do a few samples. I did 2. Y'all do 2 or 3. What we need is several samples. If we were in class and all 16 of us were there, I would just have each of us do 2. But because of the internet and cell phone problems, I don't know when some of us are going to see this thing. So do at least 2, maybe 3 if you can. And hopefully by tomorrow we'll have enough data that we can go ahead and make a useful dot plot and see what we get. Okay?
Mm-hmm.
All right. Any other questions?
Yeah, I have a question. What was the purpose of that random number at the beginning, like you used for birthday? Like,
that's just to make sure this, when I went up here and I seeded the, when I put in my birthday right here.
yeah.
That's just to make sure that all of us get a different sequence of random numbers. The way our calculators work to generate random numbers, they start with a what's called a seed value. And initially that seed value is 0 for all calculators. And since we have done the ACT, recently using these calculators. You didn't know this, but math teachers, we go through and we reset the calculators to their default settings so that everybody starts with essentially the same calculator. So now that this group of calculators that you all borrowed to take home was reset for the ACT, I'm afraid that what happened is you're all starting with the same C value, and so we will accidentally generate the same set of random numbers. So make sure we seed our calculator differently so that we're all getting a different set of random values. Okay. So that's all. That's really all I want to just make sure we're getting different random values. Okay. Any other questions?
Do you want us to do more than one for each of the 5, 10, and 25?
Yeah, do at least 2 each, and if you've got time, do 3. That would be ideal.
Okay.
It doesn't take that long to do. The main thing is just make sure that you're paying attention to how many samples you're taking, and the last value you put in is the number of samples. Okay. And the only value we need to record is just the mean of that set of data, and you'll put it either here or here or here. Either one is fine. Okay. Any other questions? All right. Well, we've been at this a good 40 minutes now, so I'll stop right here and allow you guys to do a little bit of work. Also, some of you did not get a chance to complete that 5-question quiz on sampling distributions of sample proportion on Friday, and I think I went in and I reopened that. Log into Google, not Google Classroom, AP Classroom, and make sure you answer those questions. Probably tomorrow I will post another set of questions dealing with the sampling distribution of sample means. And pretty soon I'll probably post like a couple of open response questions from these 2 topics. Okay. So it's a handy tool, especially in the situation we're in right now, because we get good quality questions. They're AP exam level questions. If you can get 3 out of 5 or 4 out of 5 of these questions, then that should give you confidence that you're on the right track. Okay. Anything else?
Were we supposed to do question 35 and 38 on whatever that page was in the book on Friday and turn that in?
That sounds like something I would ask you to do. Let me.
I think you did, but I couldn't find it posted on Classroom or anything, so I didn't
Oh,
know.
you know what? Yes, you were. This was the yeah. You were supposed to do that, and I had a little bit of excitement here after we finished class Friday, and I simply forgot to post that. So I'll go back. I'll post that as well. I'm making myself a note. That was 35 and 38, right? 35 and 38. That was from Friday. Okay. And so also, I will post the link to the Google Sheet when we're done here. I'll save this video. If you want to come back and look at it, it will be, I'll send you a link on Classroom for that. You can come back to it later. Thanks for reminding me. It wasn't my fault. It was all my daughter's fault. So blame it on Courtney. All right. Any other questions? Well, I don't know about y'all, but it does me good to see your smiling faces, or your emojis like Gracie's and Elijah's, or the top of your bed heads. But anyway, I really,
Smiling face.
there you go. That's it. There's your smiling face, Gracie. Thank you. That's the best possible smiling face I could see from you. Yeah, I miss you guys. I really do. I hope you're patient, and we'll get through it. If you know of somebody who's really, really struggling, being isolated, let me or somebody know so we can reach out to them. We want to make sure everybody gets through this, not only virus free, but with a good positive experience, I guess. All right. Well, gang, I'll talk to you tomorrow, 1 o'clock, and we'll go from there. We'll see y'all tomorrow. Thanks.
Bye.
Bye.
Bye.